The next understanding is about the central limit theorem. The central limit theorem, as mentioned, is like the most important theorem of probability. And one reason the normal distribution curve is useful because of the central limit theorem, which is like a subclass of the normal distribution curve. And it creates a random variable defined as the leverage of a large number of independent and identically distributed random variables itself, approximately normally distributed. So in particular, I can say if I have a random variable, say from a range from x1 to xn, with a mean which is represented with a mu formula and a standard deviation of sigma, then n is large and this central limit theorem can be depicted with 1 by n into x1 to the summation of xn, and is approximately normally distributed with the mean and the standard deviation represented as sigma divided by square root of n. The basic formula for the central limit theorem compares like a summation of xn minus mu of n, which is like a mean of n value divided by sigma into square root of n, and is approximately normally distributed with mean 0 and standard deviation 1. So let's get started with the coding of the central limit theorem. This is my code base, and here I create a file named central limit.py representing central limit theorem. Starting with the import libraries of the first library which we need is import numpy as np. Numpy is py, or we can say numpy is nothing but a numeric library which is needed for Python. So this can be taken as py, and afterwards the next value, or we can say this abbreviated form of alias I'll take as np. After that comes the standard library which is needed for plotting, that is matplotlib import pyplot as plt. And after this comes the basic declarations, that is for the mean value, which is the mu value, and sigma value, that is mean and standard deviation, and we need to initialize that. So let's get started with mu and sigma equals 0, 0.1 with mean and standard deviation. So these values are represented over here, and then comes s equals np dot random dot normal, and this value will be taken as mu, sigma and 1000. After this, we are just like creating the random values with mu and sigma, that is these mean and standard deviation values. So let's create variables, say for count, bins and ignored. So for that I'll mention over here as count, bins and ignored values. So that will be plt dot histogram with the value as s, 30 and normed equals true. So now let's plot the values with the formula. So let's start with the formula plotting as plt.plot. The formula starts with a bins value which has been initialized, which is nothing but creating a plotting of an histogram, 1 divided by, starting with the bracket initialization as sigma into np dot square root of next value as 2 raised to will be 2 products. So here it is 2 into np.py, where np is nothing but my numpy for numeric expression calculation. Now into np.exp, which refers to exponential, minus of bins minus mu. So bins is actually calculated with a lesser value of mu, so that is why we get a negative value, raised to 2. So minus of negative value will give you positive, that is minus of minus is always positive. Then after that, let's divide it with 2 into sigma raised to 2. So this values have been calculated properly, and after this it is important to set up the line width and everything. So starting with line width as equal to 2, color as red, and then comes the exact definition for title, that it will be represented over here as plt dot title, the value as the central limit theorem, and after that comes the exact precision with the show value, that is plt dot show. So what we are going to do now, we'll go to our command prompt and run this particular file. Now let's run the file as Python central limit dot py. This gives you the exact definition with respect to central limit with the export, like you can save this figure. So now you can see that I have a histogram with some values plotted in it, but a line which is defined over here is the curve as per the formula of the central limit theorem, which gives the exact probability listing which is needed. So this is how central limit theorem actually takes place. So this is the exact working which takes place with respect to central limit theorem. Now the next chapter is a complete new chapter where we will be starting with our hypothesis analysis, where we will be understanding about the hypothesis theorem.